Hi, this is for the correction of homework on differential equation. It's just the beginning of the chapter. And for the first question, we write the following as differential equations. Do not solve the equations. So just to give us some practice of how we go about and build differential equations. So the first one is for the height h and time t, the rate of decrease of the height of water in a tank is proportional to the square of the height. The height is h, so the rate of decrease would be dh over time, okay, with respect to time dh over dt, and that is proportional to h squared. And therefore the differential equation is going to be dh over dt is equal to the constant k times h squared. Because we are looking at a decrease, so it's going to be minus where k is going to be equal to, k is going to be greater than 0. So the first part of the question is done, and the second part, similarly, we have for the number of infected cells, okay, and time t, the rate of increase of the number of infected cells, so that's going to be dn over dt, and this is proportional to the number of, is proportional to the number of infected cells in the body at that time. Infected cells is n, so it's proportional to n, and therefore we're saying that dn over dt is equal to kn, where k also is greater than 0. The third part, which is part C of the question, the velocity v and time is t. The rate of decrease of the velocity of a particle moving in air fluid is proportional to the product of v and v plus 1. So rate of decrease of the velocity, that's dv over dt. So we're going to write dv over dt, and it's proportional to the product of v times v plus 1. So meaning that we have an equation as such, dv over dt is equal to kv times v plus 1, where k is greater than 0. And that's decrease, so if it's decreased, then it's going to be a negative. Next, for part D of the question, I have the volume V and time t, the rate at which oil is leaking from an engine, is proportional to the volume of oil in the engine at that time. So dv over dt is proportional to the volume. So dv over dt is proportional to the volume v. The volume is v basically, and so we're looking at dv over dt, okay, is equal to kv, where v is the volume, right? So yeah, proportional to the volume, that's it. Now for the part E of the question, we have for cost C and time t, the rate at which the cost of an item increases is proportional to the cube of the cost at that time. So dc over dt then, rate of increase of C, so dc over dt is proportional to the cube of the cost at time t. So that means we have then dc over dt is equal to k times c to the cube, where k is greater than 0. And for this one also, k is always greater than 0. And then for part F of the question, we have to find the differential equation given that the speed, just bear with me one moment. All right. Now you're given the speed. The rate of change of speed of a skydiver just after he jumps out of a plane is inversely proportional to e to the t over 2. So that's the rate of the speed. So the dv over dt is proportional to what did they say? To e to the t over 2. It's proportional to e to the t over 2. And therefore, I have dv over dt is equal to k times, well, hang on a second. They're saying it's inversely proportional, isn't it? Yeah, inversely. So inversely, we have to take 1 divided by this. So I have then times 1 over e to the t over 2. And if you multiply this, you're going to get k over e to the power of t over 2, where k is greater than 0. Just a few questions on differential equations, just the beginning of the chapter, as I said, to help you understand what type of equation you need to build given these types of literature when it comes to differential equation. All right, I hope that helps. Take care. There's more videos coming later on.